Okay, so the next problem is in 2.6. It says compare the amount. So it seems like the more compounding periods in the year, the more money you should make. The question is, does it make a huge difference, right? Compare the amount of money that you would have after 20 years if it's compounded twice semi-annually, 4 times quarterly, 12 times monthly, 365 days per year daily, and then hourly. Then find a way to organize, display, and explain your results to your class. Okay, so for me, my favorite way to organize things is in a table. So I'm going to do that. Let's see. They said so yearly, semi-yearly, quarterly, monthly, daily, and then hourly. So let's do that. So here's my little table, right? And so I'm going to squash that in there. So this is going to be what we already did was yearly. And then we're going to do semi-annually. This is like, if you think about semi-annual sales, right? That's 2 L's, Ms. Johnson. And then the next one is going to be quarterly. The next one is monthly, then daily, and then hourly. Okay, and so I'm going to build this. Why isn't it letting me scoot over? I'm going to build this really quick. So the equations I'm just going to use over and over and over again and just change. What am I actually changing though? So am I changing my P, my R, my N, my T? What am I changing for this particular problem? Yeah, I'm changing N. Perfect. Okay, so all I'm gonna do, so Ms. Johnson, all we're gonna do is we're gonna go back to that calculator. Yeah, I'm gonna go back to that calculator and I'm gonna change my N and I'm gonna write it over here. So I'm gonna go back here because I already have that calculation done. And I'm gonna go here, right? I'm gonna copy this and put it here. And so this right here represented yearly. So this is how much money it is. So this is, I'm gonna put my N here. So yearly is 1. And then here, I'm going to put my big A. So that was $265.33. Okay. So here, semi-annually, this is kind of getting my nerves here. Let me scooch you over. Okay, good. So here, I want to change it to my N. So it's still 20. It's still 0.05. It's still 100. But now my N changes. Now notice here, my N changes here to 2 and here to 2, right? Because your N shows up twice, down here, up here, okay? So I'm just gonna fill out this little chart here and notice here, this is 2 and this right here is $268.51. So you're like, Ms. Johnson, it's $3, not a big deal. Okay, I'm gonna change it again to 4 and to 4 here. And that's $270.15. That's 4. This is going to be 12. So again, I'm going to change this again to 12 to 12. And that's $271.26. I'm just rounding. And then daily would be 365. And down here would be 365, right? And you're like, okay, Ms. Johnson, that's $271.81. There, sorry, I just wanted to make sure. And this is 365. Like, Ms. Johnson, there's not too much of a difference. It's like almost, $5 or $6, not a big deal. Okay, and then hourly, I don't know how many hours there are in I don't know how many hours there are in a year, but I do know that there's 365 days, and then I'm going to multiply this by 24, and then I'm going to multiply up here by 24 as well. Ms. Johnson, can you do that? Yeah, I can do that. So there's my answer, $271.83. 271 and 83 cents. And this is whatever, 365 times 24. Okay, so did that make a huge difference? Did that make a huge difference? Everyone says, not too much, Wisconsin. It's like $5. Yeah, so like after 20 years, $5 extra, it's not like, oh, now I'm rich, right? That's not it at all. Okay, so that helps you understand that it does make a difference. There is more money in there, but it's not amazing. Okay, so then it turns out, let's just continue on here. So then it turns out that the value you found in your compounding problem is 100 times a very famous irrational number times E. E is an irrational number. It's non-terminating and it's non-repeating. It's kind of like pi. So here's the first couple digits, 2.7, 1828, 1828, 45, 90, 45, and so on. So like pi, E is a number that occurs in mathematics in real world situations, including exponential growth. So this number here, this E right here, you guys all see him? E is a number. He is not a variable. So there are certain variables that look like numbers, and then there are certain letters that are numbers. So yes, Sesame Street lied to you all. E is a number. It's not just the letter. This is called continuously compounding, okay? So, so one of the formulas that you'll be using is when it's compounded continuously. See this word continuously? So here it takes over our N. So here, this is compounded and we calculated semi-annually, quarterly, monthly, daily, hourly. Well, continuously kind of means like as soon as it's compounded again, but even faster than that. So we use this value here, which is 2.718281828 all the way through, right? And this is our new equation. So Ms. Johnson, when do I use this one? When it says the word, say it with me, compounded continuously. So if it says this word continuously, you want me to use PERT, shorthand PERT? Yes. P times E to the RT. Yes. So if it says compounded monthly, you want me to use this? Yeah, because the monthly tells you that the N is going to be 12. Does everybody see the difference between this equation and this equation? Okay. If you use this equation for this, it's going to give you the wrong answer, right? All right. So number 4, it is fairly typical for a savings account to be compounded monthly. Compare the amount of money in 2 savings accounts after 10 years with the same initial investment of $500 and interest rate of 3% in each account if the first account was compounded monthly and the second compounded continuously. Okay, so just for the sake of time, I want you to plug into for compounded continuously really quick right here. So if you can do that, that'd be great. All right. If you can throw into the chat, who is what number is what, that would be perfect. So someone give me where do I put 500? Where do I put 500? Yeah, 500 is P. Very good. What do I put instead of E? What do I put instead of E? So that's a trick question. You put E, right? What do you put instead of R? Oh yeah, you can put 2.718, but you can actually put E into Desmos and it'll calculate it for you. What do you put instead of R? Very good. R is 0.03. And what do you put instead of T? Very good. Okay, so I'm going to take this and I'm going to plug it into my handy dandy calculator, right? For some reason, let's do Desmos. Okay, so P is 500. E, the moment that I put E in there, it's gonna know what I'm doing. See, that's why it multiplied 500 times E. And then I'm gonna go to the R, which is 0.03 times, and again, that times went down. So again, I want to put parentheses on there. Johnson, you should know this. Yes, I know, but I'm doing it for your sakes. Times 10, close those parentheses. You should know that that exponent only applies to E. So if you use PEMDAS, right, it's going 0.03 times 10, calculate E to the whatever you just got, and then take that and multiply by 500. It is not, this exponent is not being applied to 500. It's a very different number if you did. So there's that number, and I'll snip that just for sake of time. It goes right here. Actually, wait, I will not snip right now. Okay, so then if I plug into the other one, right, to the other equation for this one, here, to compare it. They wanted you to compare it if it was compounded monthly. So then I would go 500 times 1 plus 0.03 divided by monthly. How many times a year is monthly? Everyone says, what's my N? What's my N for monthly? Yeah, it's 12. To the, and if you don't know your formula, no problem. I know it because I'm the teacher. Times 12 times T, and in this case, T was 10. So here's my 2. This is what they wanted you to compare, right? They wanted you to compare compounded continuously, and they wanted you to compare compounded monthly and see what you got, okay? And you guys are like, oh, Ms. Johnson, it's like 30 cents, not even 30 cents, right? And exactly, it's not that big of a deal. For several reasons, right? For several reasons, but do you know when to use this one? And do you know when to use this one? Why did I have to do this? What word told me to do this here? Yeah, this says monthly. Nice. What word did they tell me to use this one? Yeah, continuously. Very good. Okay, so make sure you are clear on those two. Okay, so here, then they want you to use technology to graph the two accounts, and what conclusions could you draw? So here, I'm just gonna go here. Use technology to compare the graphs of those two accounts. So I'm gonna do that, and I'm gonna make T my variable. No! Oh, look, undo works. Yay, Miss Johnson, sorry. A little bit dramatic she is. Yes, she is. Okay, so here's my two graphs, and I'm zooming out because I want to look at, I can't see my 500. There he is. Okay, there you go. There's your two equations. Miss Johnson, I only see one. I know. I'm trying to zoom in so you guys can see. How close? You guys kind of see the difference between them? I'm trying to get really close here. It's very close. Okay, very good. See, they're like kind of like next to each other if you really look. So they follow each other really, really well. I'm just going to go over a couple more things and then I'm going to let you guys go. So, okay, since E is widely known as the exponential growth and decay, let's get a little bit more familiar. So E is that number that we've done, right? They want you to create a graph on that, which that's fine. So if you go back to your Desmos calculator, so they want you to go E to the X. And let me get rid of all these guys. That's fine. It looks really funny because it's like so close, but it looks like this, right? It looks like any other exponential function. Okay. I'm trying to hustle through all of this to make sure that you guys all see this. And that's pretty much it. You should try these problems just to make sure that you understood today's lesson.